The next measurement-based interfrequency handover is triggered based on a factor of frequency priority. So for frequency priority-based interfrequency handover, that is all determined by the frequency priority which we have set in the system. So first of all, we can see from the picture here, from this diagram, we can see that the frequency layer of 2600 has been defined with a higher frequency priority as compared to another layer, which is the 900 megahertz. So in this scenario, if we want to turn on frequency priority based interfrequency handover, then this is the switch that we have to turn on, which is called frequency priority handover switch. So this switch has to be turned on, and when the user is in the low priority frequency band, the user will be instructed a measurement gap so that the user is able to perform the measurement on the another frequency band in order to proceed to the handover decision. So the trigger factor is based on the frequency priority setting, but it doesn't mean that the user will perform the handover from 900 megahertz to the 2600 megahertz without measurement. So it is not just based on the frequency priority, but in fact the user has to perform measurement first, then the eNodeB will decide whether the handover should be performed or not. So this is the frequency priority switch, frequency priority interfrequency handover switch that we have seen earlier. So there are two scenarios of frequency priority based handover, where scenario number one, the two multibands are sharing the same coverage, means they are a co-site and co-sector scenario. So in this scenario, both of the lower priority and higher priority frequency bands are sharing the same sector and same site. Hence, in this scenario, event A1 is used as a triggering condition for such measurement. So event A1, as we recall, event A1 indicates that the serving frequency quality is greater than a threshold. So that means event A1, which is sent by the user, indicates that the user is in the cell center. So that means we can assume that the user is also in the cell center of another frequency band, because in this scenario, both bands are sharing the same site and same coverage. Hence, A1 is used as a measurement, a triggering condition for measurement. So in this, for this scenario, a switch has to be turned off. So the switch is called A2 base frequency priority handover switch. So this switch has to be turned off so that A1 will be used as a triggering instead of A2. So if we look at the second scenario, where two multiple bands are having different coverage, so the both of the higher priority and lower priority frequency bands, they are not co-site or co-sector. Hence, in this case, event A2 is used as a triggering condition for measurement. So event A2 indicates that the serving frequency quality is worse than a threshold. So that means the user could not be, most likely the user is in the cell edge of the current serving cell. Hence, the user could be near to the cell in another frequency band. So in this case, A2 based frequency priority handover switch has to be turned on so that event A2 can be used as a triggering condition. So when the user is in this scenario, the user has to follow the A1 and A2 threshold, which we have mentioned earlier. And this is the setting. Where in the setting, we have to define the RSRP and RSRQ threshold for frequency priority based A1 and frequency priority based A2. So once the user send event A1 or event A2, depending on the scenario, then the init be assigned measurement gap for the user. So the user will measure another frequency. Well, then the measurement will stop only when leaf conditions are met. So if the trigger condition is event A2, then the stop condition is that the user sent event A1. So in another scenario, if the measurement triggering condition is event A1, then once the user enter measurement gap, the user is given 3 seconds, and the 3-second timer will start right after the first measurement, and right after 3 seconds, the measurement will stop. So when the user has been measuring the other frequency band, then the user has to send event A4 to report the signal quality or signal strength of the candidate cell. So that is the event A4 formula, which we need to define the event A4 RSRP or RSRQ threshold as indicated by this page. So to recall back, event A4 means that the neighbor frequency, the signal quality or signal strength of the neighbor, the candidate cell, is greater than a specific threshold. So here is where we set the threshold. The next type of handover is called distance-based measurement trigger. So distance-based measurement trigger, as indicated by the name, this handover measurement is triggered simply based on the distance between the user and the serving cell. So in this diagram, we can see that the user has been connected with cell 1 of F1. And the user has been moving away from cell 1 until the serving area of cell 4. So in this scenario, once the user moves away from cell 1 and the distance between the user and cell 1 is greater than a preset threshold, then the user will be assigned measurement gap so that the user has to perform interfrequency handover. So this is F2. So this is only for interfrequency handover. So intra-frequency handover is not triggered based on distance, because for intra-frequency, we have coverage-based handover to take care of that. So if the user has been moving away from the coverage of one serving cell, so by right, the user will trigger intra-frequency coverage-based handover when the user is moving away from the current serving cell. So in this scenario, the user has to perform handover right after this distance, because there might be no neighbor relationship defined between cell 1 and cell 4. So in this case, we need the user to perform handover with cell 3 before the drop, because there is no neighbor relationship defined between cell 4 and cell 1. So this is the distance-based handover switch which we need to turn on. And the measurement will start when the distance of the user exceeds a threshold which has been defined by this parameter, which is distance-based handover threshold for 10 seconds. Then the user enter measurement gap, and the user will delivers the measurement result in following the event A4 criteria. So if the InnoB detects that the reported TA value does not meet the distance threshold for 10 seconds, then the measurements are immediately stopped. So as we can see that the distance is measured based on the reported timing advance value, TA value. So these are all detected by the eNodeB. So the same as the event of the coverage-based handover, we are using the event A4, and the threshold of the event A4 is exactly the same with coverage-based handover. The last interfrequency handover is triggered based on uplink quality. So uplink quality is determined by eNodeB by checking the modulation encoding scheme and the initial block error rate of uplink. So once the eNodeB detected that the modulation encoding scheme used by the user is smaller than the threshold, which is at index 5, which means index 5 indicates QPSK with the coding rate of 1/3. So if the user has been using a modulation coding scheme lower than this index, at the same time the initial block error rate is greater than the threshold, which is 20%, then the eNodeB trigger the measurement for interfrequency. So the user will be receiving the measurement gap configuration, and the user has to measure interfrequency neighbor, and following by sending event A4 reports. So the user will be sending event A4 reports to the eNodeB, and the eNodeB has to decide. So this is the triggering of the measurement for event A4, where the uplink modulation encoding scheme is smaller than a threshold. At the same time, the difference between the actual initial block error rate and the target initial block error rate convergence value is greater than uplink bad quality handover initial block error rate threshold. So if the difference between the target and the actual block error rate is large, then the user might be having a very poor uplink quality. So if these two criteria are met, then the user will be receiving the order of measurement gap. While event A4 measurement control will stop if either one of the following conditions is met, where the uplink modulation encoding scheme index is now greater than a threshold, and at the same time it could be another criteria where the difference between the actual initial block error rate and the target initial block error rate is greater than another threshold, a bad quality handover initial block error rate threshold. So when the user is in the measurement gap, the user is measuring the target candidate cell, and the user will send event A4 when the A4 criteria are met, following the same configuration of the event A4 for coverage-based handover. So the RSRP and the RSRQ A4 threshold has to be defined. So we have seen all of the types of the handover now in this LTRNO basic features, including the intra-frequency handover, interfrequency blind handover, and interfrequency measurement-based handover. For the next chapter, we will be looking at another topic, which is scheduling.